Hello and welcome to the fourth video in the mini video series on Linux Essentials. In this video series, I'm providing you with some inside knowledge on the top things you should really know when using the Linux CLI, focusing on just core content, core essential content, avoiding lots of other niche areas that I don't think you really need to know. In this video then, we'll be looking at two topics. The first is going to be looking at what path is, including what an environment variable is by extension. Now, to be clear, by path I'm not referring to a directory, which you would sometimes refer to as a path. I'm talking about the path in capital letters, which is a system-wide list of directories pointing to various services on your system. What this path enables you to do is it allows utilities to be referenced at the command line without having to type in the full path to the utility's binary or executable. For example, path saves us having to type in the full directory to a utility like ls in order to list files and directories. So instead of having to type in /bin/ls to use ls, which incidentally will work of course, I can just type in ls into the command line as we've seen previously, and the shell will search through path and find a matching binary. Similarly, just to reinforce this idea, if I had Python installed on my system, I would expect to be able to just type in Python to the shell to get access to the Python interpreter. I would not expect to have to type in the entire path to the actual binary sitting on my system somewhere to use Python. So hopefully it's clear that understanding path is very important, and in fact I'd go as far as to say it's essential for any serious Linux user to know what it is and how to edit it. So we'll cover this key element first. The second part of this video, the shorter part, is going to be looking at how we can go about finding the location of executables or binaries of programs we run on our system, very quickly and easily. For example, a common use case for those who use Python in Linux is knowing where the Python executable or binary is located, as sometimes you are required to provide the path to the binary as part of a setup process, or when creating a virtual environment. There are many other reasons for wanting to know where a program is located on your system. One other example is that we may wish to confirm that what program is actually running when we type an application into the command line. Okay, so that's the introduction. That's what's on the menu. Let's head over to my desktop and get started with looking at path. But before I do, I just want to raise to your attention my Patreon account as I normally do. If you're interested in accessing videos not available on YouTube, want one-to-one support for any issues you've got with my course, or if you would just like to support my work, please do visit my Patreon account. Okay, so here we are on my desktop, ready to go in my bash terminal in my user-pi's home directory. Let's first talk about utilities and programs you may wish to run in Linux then. There are quite literally an unlimited variety of options available to you for running applications on your Linux system, ranging from things as simple as ls, for listing files and directories, which is located in the binary directory, which we've seen already, to things more complex like Nano, Apache Web Server, and interpreters like R and Python, and compilers like G++ for writing your own software. Additionally, the language of choice for scripting in Linux is shell script, as it is supported natively by the shell terminal. And perhaps later I'll record a video on shell scripting, which opens an enormous amount of potential. The point I'm making here though is that because running software on your Linux system is the whole point of running a Linux system in the first place, the need to understand path is critical, as path makes running that software at the CLI much easier, and is in fact often essential in allowing one piece of software to find and run another with minimum configuration and hassle. Okay, so let's get going then. Type the following little piece of shell script into your terminal. Type as I type, echo $path, and press enter. This is the standard way of finding out what is in your path variable. The echo command is the general scripting command to print or output to screen. A shell variable is referenced using the $, and path is a variable, hence $path. Now note that path is all in capitals, that is required. And as I've mentioned, path is an environment variable and cannot be used for another purpose without breaking your system. What we can see by running this short piece of shell script is a colon-separated list of paths. This means that between each colon is a system path pointing to something that can be executed. We can add more of these paths should we wish, and I'll show you how to shortly. So we know what path physically is. We've seen it now. It's a list of directories or paths to utilities which can be executed, but it's also worth knowing that path is, as briefly mentioned before, one of many environment variables. So let's pause on path just for a minute before we get our teeth into it properly and talk about environment variables. To find out what environment variables are currently available on your system, you just have to type in env and press enter. This is fairly easy to remember. Env, it's the first part of environment, and as we can see, path is present just here in my environment variable list, showing the full list of directories present which we saw when we typed in our small line of shell script above. An environment variable is a system-wide variable for a given user for a given environment or session. This means they are ephemeral by definition, i.e., if you were to add one and then log out and log in again, you'll find it has disappeared. And this is actually an important feature of environment variables, and therefore by extension, path, which has the same behavior. For example, let's add an environment variable just for fun and for demonstration. We do this as follows. Export is the command. I'm going to name my environment variable myCatName, and I'm going to give it a title of Bob, or a name of Bob. This isn't actually the name of my cat, but just for fun, let's call him Bob. This is how we add an environment variable for our current user to our current terminal session. Now let's just check that it's there now by typing env in again. A little bit of searching. My cat's name, Bob, there it is. Okay, so we have added an environment variable. Now, why would you do this, you may be asking, particularly so temporarily as it is? Well, the answer is that being able to set environment variables is essential for DevOps type jobs, i.e. jobs where you are managing and deploying systems and software. They allow us to define and store variables on a system-wide scale, which can be used across processes, programming languages, and applications easily, as all of these things can access environment variables. They are also convenient for storing secrets temporarily, as they are, as mentioned, ephemeral or temporary, and will be removed when a new session is started. We can remove an environment variable we have created using unset as follows. Now if we take a look, it was up here, it has now disappeared. We can see that it has gone. Okay, so you can see how to add and remove environment variables, and I admit this may not be immediately useful for you, but I assure you that if you get into deployment or DevOps on your system, these can be very useful things to understand and be able to manipulate, or at the very least, just be aware of. Before we wrap up with environment variables, I mentioned that they are ephemeral to a session and user. Well, that isn't always the case. We can actually set them permanently for a given user by editing a particular file. So for the sake of completeness, I'll show this briefly here before I move back onto the topic of path. Type as I type, nano, to use the nano text editor, home directory /bash rc. So here we're using the nano text editor to edit the bash rc file. As a side point, in case you're wondering, the dot in front of the file name means that it is a hidden file. This means if you use ls, it won't show up. You will instead have to use ls-a to show it, where a stands for all. Okay, I'm going to press enter. I'll scroll down to the bottom, using page down till I get to the bottom of the file. Now we can add the same line inside this file as we did on the command line. Export my cat's name equals Bob, for example. And if I saved this, which I won't here, each time a new session is started by my user, this environment variable will be set for me, because bashrc will be run when the terminal is created, including our new export line. But I don't wish that to be saved. Okay, with environment variables' existence and general purpose understood, let's get back to path then, one of the many environment variables. Path is a highly important environment variable because it is used by the shell to find applications. For example, if I type in Python 3 into my command line, you can see that I have now got my Python interpreter open. It isn't some low-level system magic which is making this possible, it's the presence of the system-wide path environment variable. Let me show why. Let's look at the content of path again. Like we did before, so I'm going to type in echo path. Now I could have used the env command and shown it along with the other environment variables, but I prefer to be a little bit more specific to keep things tidy. If we look, you'll see a path called user bin. It's just here within path, which I can tell you contains the Python binary for Python 3. This is why typing Python 3 at the CLI just works. The shell finds the binary called Python 3 in that directory and runs it when we type in Python 3 into the command line. So, typing Python 3 does exactly the same as doing this, which of course will work. This is of course A, more to type, and B, far less user-friendly, as we have to remember it every time. Okay, so hopefully that's fully understood. Now before we leave path behind, let me show you how to edit it. Why would you do this, you may be thinking? Well, if you want to be able to run something at the command line by typing in the name of the binary without passing the explicit path like we just did with Python, then we'll need the path defined in the path variable. Also, often, applications will require you to have another application available via the path to work properly, such as Python for example. If it can't find it, you may get an error message asking you to make sure it is in your system path. This may be an error message you have seen before when you've tried to install software. So sometimes you'll need to add something to path to make something else work. Here is how we can add elements to path. Firstly, as mentioned, path is an environment variable and therefore it is ephemeral. So here is how to add something to your path for the current session only. The syntax is export path equals, so I'm basically setting the entire path environment variable in one go. I'm going to make it equal to what it is currently, which is referencing path using the $sign. I'm then going to add a colon for the next delimiter, followed by a directory. This is the syntax for adding a path. It is a little bit of script, and it's basically saying set path now equal to what path was before, with an additional colon for the delimiter, and then the directory I wish to add. Okay, but let's make this interesting before we run this command by writing a really simple shell script that can be executed to prove it works. Okay, so first let's create that executable script. We'll use nano to create the script content and I'll call the file hello. So nano, I'll put it into my home directory and I'll call it hello. Press enter. Okay, now I'm going to add a line of script. Echo to output to the terminal, hello world. Now this is about as simple as a shell script can get. Strictly speaking though, we should include something called a shebang at the top of this script, which will identify the script as a bash script. But in this case we won't, as it isn't relevant to this video and the script will work without it. Also, strictly speaking, it would be better if we named the file hello.sh, as that is the extension often associated with shell scripts, But again, we won't, because extensions in Linux are for semantic value only, and for this demo, it really doesn't matter. Right, so we'll save that and exit nano. With that done, we have a shell script ready to roll. The only problem is, when creating a new text file, by default, it isn't executable. So we can make it executable by doing the following. We're going to use chmod plus x followed by the name of the application or file. So chmod plus x hello. The plus x means add executable permissions. We'll talk about that in a later video when we talk about permissions on files, but for now, to add executable permissions to a file you've just created, you just need chmod plus x followed by the file name. Okay, so now that it's executable, we can run it as follows, /hello. And there we go, hello world, great. So none of that is really part of this course, but the point is, say we now wish to be able to use our hello script from any directory and not have to remember the location of the hello script each time. Well, we know what to do. We add it to the path environment variable, so let's do that. Export path colon export path equals, we reference a variable with the $, so we're saying I want new path to equal old path, colon as a new delimiter, /, and then I'm going to use my home directory because that's where the hello script is located. Okay, great. So I'm just going to navigate now to the root of my file system just to prove a point that I'm in a different location. So I'm going to do that by doing cd ... to go up one. I'm going to use a / and I'm going to do it again so that I can go up 2 directories in one go. Okay. Let's just check where I am then, using the present working directory command pwd. There we go, I'm at the root of my file system. Okay, so let's try and run the script using just the name of the utility I want to run. And there we go. By all intents and purposes, that shouldn't work. There's no script called hello at the root of the file system, but path knows where to go to get it. Isn't that brilliant? So let's now very quickly undo what I've just done in order to keep our system nice and clean. So I'm going to go back to my home directory. I'm now going to remove the hello script. Now, removing a path entry is a bit more tricky. It is doable in a single line of code, but for the sake of this simplistic video, I'm going to simply log out and log back in again, because as mentioned previously, environment variables and therefore path are ephemeral, and anything you've added in this way will be lost when you log back in. So I'm going to exit. I'm going to now SSH back in using my SSH alias pi4. There we go. Excellent. And then if we have a look at path, we should find that, yes, there's no home pi at the end, which there would have been previously. Okay. Finally then, changes to path can be made permanent, similarly to environment variables for a given user, if we edit the bash rc file. So let's do that now, just to complete this picture. I'm going to type in nano to use the nano text editor, and I'm going to edit the bash rc hidden file located in my user's home directory. We've done this before. There we go. I'm going to go right to the bottom of this file. So now what I'm going to do is I'm going to type in the export command that we'd used before to edit the path, but to do it only for the single session. But this time it's going to be for every session that I open. So export path equals the original path. That's a colon to create a new delimiter, home pi /. Save that. Okay, so export new path equals old path with an additional delimiter of a colon followed by my new path. Okay. Okay, so if I exit, I now go back in again. What should have happened is the bashrc file will have been run when the terminal was created, and as such the path was modified with my addition of home pi, and we can check that with echo path. And there we go, home pi is located at the end. So let's now remove that. Again, the easiest way is to log out and log back in again. But first we need to remove the line we added from the bashrc file. So using up at the command line, I'm going to get to the nano command for bashrc. I'm going to go down to the bottom using page down, and I'm going to cut that out and save it without the extra command. So now if I exit, log back in again, and then echo out the path environment variable, we can see that the home directory has gone away. Right, that's it for path and environment variables then. You know what they are, how to check out what's in them, how to add them, remove them in a simple way, and why they're important. You now know why it's really important to know what they are and how to manipulate them. Let's move on then to the second and much shorter part of this video, and that is how to find applications on your system. Okay, so when I type in Python 3 as I did before, the interpreter starts. We now know this is because the path to the interpreter is somewhere in my path environment variable. But where? I told you last time because I already knew the answer. But how did I know this? How did I know it was located where I said it was located? Now it could be any of the paths in the path environment variable. How did I know which one it was? This is how. There is a utility. There are actually two useful utilities. The first one is where is. So if I type in, where is, and then followed by Python 3 in this particular example, the where is tool will show me all of the paths associated with this string Python 3. The where is tool comes with most distributions. What it's doing is searching through the path environment variable to find the applications which match the search string. In this case, it's given me loads of examples. This is because I've got loads of instances of Python 3 interpreters on my Raspberry Pi. This actually isn't an uncommon thing with Python, because with Python in particular, people and applications often work within virtual environments which isolate them from the whole system, and often, as a consequence, there's more than one interpreter available. So it can be very handy to be able to list all of them. We can pretty much pick any of these to run our Python application. So instead of typing in Python 3, we could type in user bin Python 3, and that'll work. We could type in user bin Python 3.7, and that'll work. We could type in user bin Python 3m, which is also an entry, and that'll work. Okay, you get the idea. So this is really useful. It shows all instances of utilities in locations likely to be a utility which match our string. Now, how do we know which of these various binaries are used when we type in Python 3 to the CLI? Now, I mentioned I actually happen to know which one it is, and I know it is this one. But how do I know it's this one? Well, we find this out with the following command. Instead of where is, we're going to use which. So which Python 3. And there it is. So this is very important. It will tell us exactly which path is being used for the Python 3 command, and where is will tell us all locations matching our search criteria for that application. Both are really useful tools to know and bear in mind. So you can see for Python 3, it is using, as mentioned, user bin Python 3. Okay, lastly then, a question which may be hovering around in your mind at this point is, okay, so if you've got multiple binaries with the same name which are all in path, how does path know which one to choose? And when I type the binary into the CLI, why is it user bin Python 3 is used as the path for Python 3 rather than the others that we've seen? The reason is actually quite painfully simple. It's the first path in the path list which matches Python 3. There are multiple interpreters in the user bin directory, but Python 3 is the first one that will match the term Python 3 perfectly. It's that simple. You can rearrange your path to force a default if you have multiple binaries of the same thing in different places by making sure the one you want is at the top of the list. But that's for another video really, and of course if you need, you could always Google the answer. Okay, that's it for this video then. I hope you found it insightful and useful, and if you wouldn't mind liking the video and subscribing to my video series, I'd very much appreciate it. It keeps me going making these videos, and it makes it worthwhile. Also, if you'd like to contribute, please do have a look at my Patreon account as well. Okay, thank you very much, and I will see you in the next video.